So let me minimize my Zoom window here. Okay. Okay, so like I said, we're going to be talking about in this first module here about tidy data and the Tidyverse, and in particular, this really awesome package called dplyr. So what I'd like to, next slide here, goals for this module. I'm going to talk a little bit to start about what tidy data is and why it's important. Essentially, if you want to do any kind of data analysis in any sort of reproducible, flexible, efficient way, you have to make sure your data is in the right form. It's tidy, it's ready to go, and we'll be talking about that. Then we'll talk about why tidy data is important in the R ecosystem, and particularly about this awesome set of packages known as the Tidyverse. And then we'll be talking about one package in particular in the Tidyverse called dplyr that does some really cool stuff with data manipulations and operations. Okay, so first I want to talk a little bit about tidy data, just to orient people here. Okay, here, one second. There we go. Okay, so tidy and messy. I want to put some caveats on these terms here. Messy sometimes has this connotations of being bad, negative, whereas tidy is good. And I don't mean that here. What I mean here is that messy data is essentially data that's not immediately ready to do data analysis on. Messy data could have problems. There could be issues in the data, but that's not sort of necessarily the key problem. The key is that it's not ready to work with, to even start looking if there's problems. You're not ready to analyze that kind of data. Compare that to tidy data. This is data that's in some consistent format and supports the data analysis process. And again, getting your data into a tidy format is something that's really important for starting things off. So don't equate messy with bad and tidy with good necessarily, just that for data analysis, we want to get to this tidy state. And I'll talk about what that is, particularly in the R ecosystem here in a few slides. There's a principle here, or a quote here from Leo Tolstoy that also applies to data. And it's the idea that happy families are all alike, but every unhappy family is unhappy in its own way. And how does this apply to data? Well, this is a modification of that quote by Hadley Wickham. If you've been in the R community for any length of time, you probably heard Hadley's name. He's a giant in the R community. He wrote the ggplot2 package, lots of the dplyr or Tidyverse packages, and he's just a really big figure in the community. And this is a quote that he uses sometimes when he teaches, that tidy data sets are all alike. That's good. There's sort of a consistency in them, but messy data sets are messy in their own ways, and that causes problems. We can't reason about them. They're difficult to work with. In fact, they might all require their own unique solutions to deal with them. So that's sort of an idea about tidy data sets. And the reality is most real world data sets are messy. If you download, say, a CSV file, random CSV file off the internet, there might be all kinds of issues with it. It might be very messy. It might be difficult to work with. But tidy data is all structured in the same way. And that's really useful, because if you have this consistent structure that you know and can rely on, then you can do all the downstream processing with it a lot more easily. So you know what to expect and you can work with it. And that's a really important part of tidy data. Data can be messy in all kinds of ways. So maybe you have an Excel spreadsheet here. This is like a professor who's keeping track of their scores, and they have some additional header rows here, and they have some boxes here that aren't really captured well. And there's all kinds of things about this particular spreadsheet that visually is okay. We can parse this, but actually if you were to do data analysis on it, it would be difficult to work with. A lot of times we'll get proprietary data formats that are locked away in formats that we can't read, and those are difficult to work with. I've had cases where I've had to extract data from .png images. So a computer can't even copy and paste that text. You actually would have to go and re-enter it. That's not good. And a lot of times you just have files that are formatted improperly. If you were to sort of try to read this CSV type file into R or other packages, it would complain because there's inconsistencies on the number of rows and columns here. So messy data can be messy in all kinds of ways. It's good to look out for it, but they're all often have unique challenges. Messy data is hard to work with, like I said. So the unclear structure and organization of the data makes it difficult to reason about and understand. Okay, and that if you can't understand your data well, that you're not going to have any chance of being able to do any kind of efficient data analysis on it. Yeah, obviously some other points here, we don't need to go into them, but we don't want the messiness of the data to be a part of challenge for our data analysis. We want to get that out of the way and make something nice and clean that we can work with. I want to stress that messy data, I mentioned this before, isn't necessarily bad data. Just because a data set is messy doesn't mean that the data itself is bad. It just might be in a format that's not useful for doing data analysis with. So don't necessarily equate messy with bad, just that you might need to do some work to get it into a state that's ready to work with. That being said, messy data could be a sign of lurking data problems. There could be fundamental problems with the data. So you have to put on your detective hat and be aware that messy data may have some problems with it that you need to check out, you need to work with and understand before you proceed with data analysis. Let's talk about tidy data in the R ecosystem. Tidy data has a very specific kind of meaning here, and it all comes down to the idea that every piece of data lives in its own organized place. Just like if you had your closet and you put your shirts and your pants in certain places in your closet, they have a place where they go and they're organized and you understand that organization. That's what tidy data is about. And to start out, each variable, and these are the things that you are measuring, these go in their own columns. So let's say this looks like some kind of medical kind of data set here. We have a country by year, the number of cases, and then the population of that particular country. The things we're measuring are the name of the country, the year of the measurement, the cases, the populations. So those are our columns. Those are the things we're measuring. Those go in their own columns. The observations are the rows. Those are the things that you're making observations on. So in this case, I would say the observations are the countries here. Each row represents a particular country measurement for a given year. And those observations are in our rows. And then, like I said, each value goes in its own cell in the table. Okay. If you do that, then you have a nice tidy data system. You have a structure that you can understand and you can work with in your data analysis. And when we look at the dplyr examples going forward in the next section here, you'll understand why it's useful to be able to have this nice consistent structure. Let's take a look at this data table here. This is a tidy data table. If you've worked with R, you may recognize this particular data set. We'll talk about it more in a little bit, but just look at this. This is a tidy data table here, and just take a look at it. You can probably piece together what this table is about just because it's well structured. These are the column names here at the top. And you can probably understand what it is because it's well structured. If this was a messy data set, you may not be able to really understand what it is, but because it's a tidy data set, we can start to understand what it is. This is from the so-called MT-CARS data set. It's a well-used data set, particularly in R tutorials, and it's part of the basic R installation. So everybody has access to this data set. We'll show this in some examples here. But we can see that each row, each observation is a car, and then we're making observations about the cars. So those go into our columns. So for example, the miles per gallon of a given car, how many cylinders it has, its weight, and some other properties here. So because this is a tidy data table, it's actually, we can start to understand what it is, even without getting any additional information, and that's a good thing. Let me note that tidy data and data tables, like we said, aren't the only way to go. There are other structures that you might use in certain formats, certain fields. For example, you might have other data structures that are used to optimize the storage or performance of particular data. Maybe if you have video data, or maybe scientific data with very particular structures, you might have a completely different format that doesn't fit in this tidy rectangular data table. That's okay. tidy data is not the only way to go. But if your data can fit into a rectangular data structure, a nice tidy format is usually the way you want to go. And if your data is not in that format, you want to try to get it into that kind of tidy structure, because it's really going to help your analysis. We talked about the rows and columns. These are variables and observations. Sometimes those things need to switch around depending upon how you want to work with your data. Sometimes rows and variables, the differentiation between those things is not always clear, or you might need to swap those in different contexts. So just note that there could be some flexibility in what you define observations and rows on. And data tidiness, it takes effort to make data tidy, particularly if the starting data is very messy. And so there isn't necessarily always a black and white between completely tidy and completely messy data. And depending upon how much effort you need to put into something, you may have different levels of tidiness for your data. Just be on the lookout for messy data. And a couple pieces here. If the data structure is not clear or inconsistent, it's probably messy. That's a warning sign. This happens a lot if multiple pieces of information are stored in a same single cell. So this particular data takes the sex of an individual and their age, and they're linked together, and they have this underscore between them as a single entity that shows up in a data table. And I've dealt with some looked at some government data. If you go to data.gov, there's lots of data sets you can download, and you'll see these kinds of things happening a lot, where they combine individual pieces of data in one field in your cell. That's a bad thing. You want to be able to split these things out so you can work with them. And then these two main things where you have variables spread across multiple columns, or vice versa, observations spread across multiple rows. And it's kind of hard to say, but you just need to look at your sort of the messiness of the data to really deal with what's there. Everything can have its own unique problems. John, I think have any questions popped up? Any questions or comments?
Yes, we have one question. Do you manually tidy in the male age 16 example, or did you write code that makes these tidy?
Yes, that's a great question. So let me see. Yes, so there is a package called Tidyr. Okay, let me use that as a segue into the sort of the next slide here. So going from messy to tidy data takes work. There's no magic wand that you can just sort of wave over your data and make everything come out nice and tidy. It takes time. And the dirty secret of being a data scientist, you probably have heard this or not, but the idea is that we spend a non-trivial amount of time cleaning data up, particularly if we're working on a new problem. People talk about, you spend 90% of your time just getting your data cleaned up, and 10% of the time doing something useful, or, building models or doing machine learning. A lot of the time is actually just spent on the kind of this more boring, more mundane stuff. This is a process. Essentially, to become an effective data scientist, you really need to build up a toolkit of methods and techniques that will allow you to clean up code, clean up data, so that you can find these problems, recognize them, and fix them. And to this previous question about this kind of data here, you can definitely clean this up in a variety of ways. And there's a package called Tidyr. It's part of the Tidyverse ecosystem. It has lots of functions that allow you to essentially deal with these kinds of problems that we're talking with. There's a particular function called, is it separate? I'm blanking, but there's a function here where you give it a column name where you'd see this data, and then a regular expression that would essentially look for this structure here, this underscore, and it would take these two values and separate them into their own unique columns. So the age would go into one column, male would go, or the sex would go into another column. You'd actually probably want to do another round of cleanup. You'd want to get rid of the age, because this is not a number. The age would make this as a character string. So you actually want to get rid of the age. And so there'd be other functions that you could do that. But the idea is you'd want to clean all this stuff up in code. You would not, you can do this. I don't suggest it, but you could go and clean this up by hand, but you really don't want to do that. And this Tidyr package in the Tidyverse ecosystem allows you to deal with lots of these different kinds of problems. All right. Yeah, John and Pablo, feel free to uh, uh, let
They
me
just
know if
said
there's any
thanks.
questions. Yeah. Oh yeah, no problem. And anybody, please feel free to unmute too if you have any questions or comments too. You might have some perspectives from your own work. Feel free to chime in. Okay, so I talked about this Tidyverse, a set of packages. This was really kind of a game changer, I'd say, in the R ecosystem. In the last, goodness, has it been 5 or more years here? This is a relatively newer part of the R ecosystem, this Tidyverse, and it's really changed the way people approach data analysis um, in R. And effectively, it covers the whole ecosystem of data analysis, from reading data to making it clean, to analyzing the data, to visualizing data, to modeling data. All these things are a part of the Tidyverse, and they're made up of a bunch of these individual packages. So these are the different packages. Some of them, there's a lot more, but some of these different packages here. We're going to talk about dplyr here in a little bit. We're going to talk about ggplot2 in the next section. If you want to read data, you'd use this readr package. I think I summed this up here. So for data viz, like I said, is ggplot2. dplyr is about data manipulation and pipelines, and we have all these read functions here to read and tidy data, and then some other context specific kinds of packages. These are the core Tidyverse packages, but there are probably hundreds of additional sort of packages in the quote larger Tidyverse that people contribute. If you work in a specific field, there might be a Tidyverse type package that could be appropriate for the kind of data that you work with. So it would be worth searching the internet for maybe your particular field of interest and see if there are some tidy packages to work on. It really makes working with data a lot easier. Yeah, go ahead, John.
We have a question. What does the term opinionated mean in the context of the Tidyverse?
Opinionated, that's great. So again, so Hadley Wickham, again, he's sort of the main architect of the Tidyverse. It's opinionated because there are some assumptions about what should take place and how data is manipulated in the Tidyverse. One is that the fundamental input to essentially these packages and the functions that use on them are tidy data frames, data tables, like I talked about. Okay, so that's an opinion we're stating an opinion that data analysis should be done with tidy data tables. And that's not necessarily true in other packages. Base R doesn't necessarily do that. You might have more complex data structures that you would use, and the Tidyverse says, nope. If you're in the Tidyverse, you use tidy data tables. And for example, lots of functions in the Tidyverse, particularly in the dplyr, you give one of these functions a tidy data table and it spits out a tidy data table. That's kind of a requirement here, that you give it a data table and you give back a tidy data table. So these are some opinions that are being set by the Tidyverse. At the sake of perhaps less flexibility, we don't have the world of possibilities we can work with, but at the benefit of a very consistent, easy to understand and reason about ecosystem to work with data. Okay, so those are the opinions there. So the Tidyverse doesn't stray away from making decisions, quote, for the benefit of the user. Think of it like Apple. Apple's a very opinionated company about how it makes computers and so on, and that has pros and cons with it. So that's the same kind of idea here. Okay, to install the Tidyverse packages, it's very easy. This is installing the core Tidyverse packages. If you're in RStudio, you can go into Tools, Install Packages, and then you would enter Tidyverse here and click Install. You can do it from the console just by typing Install Packages Tidyverse. The Tidyverse isn't a package itself. It's really just a wrapper around all these other individual packages here. So when you install it, it will install these other things for you. And there's a way to keep the packages up to date through this wrapper package, and that's useful. I'll show you that when you load this package, it will actually go and load all these individual packages for you on the back end. So it just makes things a little bit easier to work with. And again, these core packages were chosen because they encompass a large variety of the whole data analysis process. Or to say that another way, if you're going to go do a data analysis, you can load the Tidyverse package and essentially have the main tools at your disposal that you'll probably need for a given data analysis. Okay, so boy, that was a lot on tidy data. let me just recap here. So again, tidy data is essentially well-structured data that's ready for analysis. And as we said, each row is an observation, each column is a variable, and each individual piece of data goes in its own cell. If you adhere to those rules, then you have a tidy data table. Messy data is everywhere, and it takes work to get messy data clean. And then talked about the Tidyverse. After this, if you're not familiar with Tidyverse, by the way, I would go and I think I have some links here at the end of the slides, but it's worth going and just browsing the Tidyverse website and just kind of seeing what's there, reading some of the documents. I think it's really useful. You might find a package there that solves a particular problem that you might be having. Okay, let's get into sort of the meat of it, look at some R code now. We're going to talk about data manipulation with dplyr. This is an amazing package. It changed the way I think about data analysis. It's really a fundamental package that has really influenced people doing data analysis with R. If you use R in any capacity, you need to know about this package. Is kind of the meat of it here. So dplyr is like the graphic here and the name imply, a piece of pliers. Think about this as a tool for doing data manipulation. And it essentially defines fundamental operations that encompass most data analysis tasks. Again, like the opinionated part, it assumes you already have tidy data. And I'll show you here at the end that you can use this pipelining coding structure that's really cool, that allows you to do actually really pretty complex operations in a straightforward and natural way. These kinds of pipelines almost read like English if you just were to read them out, and they're really cool and flexible and powerful. We'll see what one of those looks like here in a little bit. Okay, so dplyr is a package, an R package. Okay, and defines a bunch of functions inside the package that we're going to use to do data manipulations. And think of these functions as verbs. Okay, actions we're going to be performing on tidy data tables. Again, so think of these operations as sort of data manipulation verbs. These are functions that we're going to call. Fortunately, there aren't many of these verbs. I'll show you on the next slide, just really a small set of these things. So hopefully they should be relatively easy to remember and work with. And I think the really key thing is if we think about these data manipulation verbs, you can really focus on your question that you're trying to answer rather than the mechanics of how to answer that question. So probably maybe in your work or in school, you've had an assignment, maybe a data analysis assignment, and you might spend a lot of time up front just trying to figure out like what code do I actually need to type in order to get the work done, and you're struggling with sort of the code part of it. The idea between dplyr is hopefully we can get this small set of operations that allow you to just understand what they are, know what they do, and then really focus on the question rather than sort of the code and the syntax to get it to happen. So let's talk about what these data manipulation verbs are. Interesting, just a few of them here in these rows of the tables, but these encompass most of the things that you'd actually want to do on a data table. So this first operation, add a column to a data table. So imagine we have some data frame. There's an operation that allows us to tack on a new column. Typically, this would occur if you have some additional data in your table and you want to compute a new value from the existing data in your table. You can use this operation to add on a column. Sometimes we have lots of columns of our data. Like you might get a data set that has 100 different columns and you only care about 3. This allows you to focus in on just specific columns that you care about and get rid of all the other stuff. That can be useful just for your own mental sanity in trying to deal with complex data. This next one is really powerful, subsetting to specific rows. So this is typically used in the context of, I have a bunch of rows in my data, but I'm only interested in, say, people who got grades 80% or higher on a given test, or I'm only interested in cars that have 8 cylinders. There's a way to do that here with filtering. Sometimes you want to reorder things, so you just want to sort in different ways. This last two is extremely powerful. We use it all the time in data analysis here. This combined thing of grouping subsets of your data. So imagine, let's say we want to group by maybe gender, where we want to compute the drug effectiveness on males versus females. we could take our data frame and group it by gender, and it will create two little subtables for us. And then we can use this summarize command to compute summaries on those two things. So like the drug effectiveness by gender, we can group by gender and then calculate the mean effectiveness of the drug, and we'll get a summary out for those things that we grouped on. We'll see an example here, but that's extremely powerful and really cool. The dplyr package defines all of these operations by these data manipulation verbs here: mutate, select, filter, arrange, group by, and summarize. Hopefully the names give you an idea of what they do, and that's the purpose. So let's take a look at some of these examples here. And I'll run some R code as well, so we can see these in practice. We're going to use this empty cars data set. It's a small data table, kind of basic, trivial kind of data set here, but hopefully will be easy to understand here. You can access this from the R terminal just by typing empty cars. Let me actually let me stop, get it out of Excel here, and let me move Zoom, and let me go to our studio here, and let's get a new window up. If you type, sorry, Zoom is always in the way. If you type empty cars at a completely new R session, empty cars, and hit return, you will get this data. It comes installed by default, so you'll be able to see this data table. So we'll be looking at some examples here with the empty cars data set. Okay, let's see here. Okay, so a few, let's see, I might keep this out. Can people see the slides okay? I can go back and forth between RStudio if I'm not in presentation mode. Okay, great. Okay, so a couple things about the dplyr verbs here. The first argument of the function is always a tidy data table. Okay, so like this mutate function, the first thing that comes inside of the function call has to be your tidy data table, whatever that happens to be. And it's going to return back a data table as well. These dots here are additional arguments. Different functions here are going to maybe take different additional arguments. We'll see some examples of those. Those go after the first argument. Just know that the input data table has to be the first argument. And like I said, these dplyr verbs, these functions always give back a data frame. So for example, if we wanted to mutate, add a new column to our empty cars data set, we could assign the output of this to a new data table. I call empty cars 2, just as some modified version of this. The mutate command does not modify in place the table. Okay, so if you run this function, empty cars is unaffected. If we want to save those results, we need to make sure we assign that back to a variable. Okay, let's take a look at I have some slides here actually. Let me just run through these, I think interactively. I think that would be easier to do. But if you want for reference later on, you can go through these slides that sort of walk you through these different dplyr verbs that I talked about. Okay, how visible is, actually, let me actually get some code here. How visible is this R code? Do we need it any bigger? We want to be able to read up here and down here. Is this readable, or bigger would be better?
It's readable. It's
readable. Thank you very much. Okay, great. Okay, so first of all, let's take a look at, we got to load the Tidyverse package. This is, like I said, going to load all those core packages that we saw before. Let's take a look at the terminal down here, the console down here, when I run this line. And by the way, just as a tip, you may or may not know this, as you work with code in the editor here, if you put the cursor on any particular line and you push Command or Control on Windows, enter or return, it will run that line in the console down here. That's a useful little thing to do if you want to look at code here. Okay, so we just ran this line of code. Let's look at the output here. So it says it's attaching packages. It tells us that it attached these 8 packages here. These are the core Tidyverse packages. So it let us know what it loaded up for us. This conflict messages down here gives people some pause here. We have these red X's and so on. By and large, we don't need to worry about this too much. It's just saying that it's defining some new functions that happen to have the same name as these filter and lag functions. But in practice, you don't need to worry about that too much. So, okay, let's take a look at the mutate command. Do you remember what mutate does? This adds a new column to our data set, to our data table. So let's look at empty cars again. Okay, this is what the data table looks like. we have all these different columns here. Mutate says we're going to add a new column onto it. And we define that by this second argument. Remember, the first argument has to be the input data table. So this says we're going to define a new column called qmin. I'll describe this in just a second. Qmin is going to equal qsec divided by 60. So this is for a car. Imagine it's going around a track, and this is, I think, the quarter mile time or something like this. This is how fast it takes a car to go around the quarter mile in seconds. Let's say we want to compute a new variable, which is that same time, but in minutes. So we'll divide this by 60. And let's take a look at what, remember our output here. Okay, let's see what happens when we actually do this mutate. And let's print out this empty cars2 data frame. It's the same table as above, but now we got this new column called qmin. Okay, so we took some.
We have a question.
Yeah.
What happens if the new column name already exists in the data frame?
Let's check that out. You know, that's what I love. I'm in the sciences, and I have lots of friends that are in the lab. And like, if they have questions like that, they have to go into the lab and like mix chemicals together and stuff. And that takes time and so on. The cool thing about coding is that we can actually just try that out in our code and run it and see what happens. So let's say MPG here. Let's use that as a column name. I mean, that exists here. Let's see what happens. MPG, let's run this. And let's see what happened to empty cars2. Oh goodness. Okay, we don't have that qmin column anymore. And that MPG column, which was miles per gallon, now just got overwritten with our own calculation here. Okay, so you can certainly do it. And it does what you said, but it just overwrote the column. So be careful, I guess, is the thought of that. Let's put this back to qmin. Okay, so again, this is adding columns on. You typically do this when you want to compute a new column with data that you already have in your data frame. You want to transform it in some way, you want to compute something new, or maybe you have some external data that you want to calculate on as well. Okay, the select verb. This was about selecting specific columns. And again, you typically do this because you want to zoom in on your data. You just want to ignore all these other columns that you don't necessarily care about for your analysis. So that's what select is. It's mainly an organizational task to make data look less complex. So again, let's see what happens. Let's select empty cars here. Again, this has to be our first argument. Then from here on out, we just list a bunch of column names. We can put comma and keep going here. You know, we could put another column is called VS. So we could add that column here. Let's say we wanted these 3 columns. Let's run this particular code here and print it out. Okay, so now instead of having all of those columns in the table, we just got these 3, miles per gallon, horsepower, and VS, and those showed up there. Let's say you wanted every single column except one of the columns. It would be tedious to type all of those columns out, so we can actually just use the negative sign as well. This says get rid of a column. In this case, we're going to get rid of the weight column here. So let's take a look at that. Empty cars. It's the same data set, except weight does not now, WT does not appear as a column. We got rid of it. Okay. This is mainly, again, about sort of viewing the data. This doesn't really manipulate the data per se in any way, except getting rid of columns. This filter example, though, is interesting. This allows us to give some conditional expressions, for example, that allow us to filter to specific rows in the table. So let's look at this first example here. This is the number of cylinders in a given car. Let's say we're only interested in cars that have 4 cylinders. Let's look at our empty cars again. Let's see just look at the space here. So our cylinder column is here, and it looks like it could be 6 cylinders, 4 cylinders, or 8 cylinders. If we wanted to do like a summary, like take an average or something like that, on this whole table, it would mix all of these different cylinders up. But if we wanted just for cars that had 4 cylinders, we can use the filter command. Let's take a look at what that looks like. If we look here, now we've taken this data table, we've gotten rid of all the other rows and focused in on the ones that just have 4 cylinders. And we can do that, for example. And again, we use these conditional expressions here. You may or may not be familiar with these in R. If you're not, it's a fundamental thing to learn. But essentially, we give conditions. In this case, this says, give us all the rows that have of cars that have horsepower greater than 200. So let's take a look at that. And another table here. Horsepower, you can see here, are all above 200. You can combine expressions here. So let's say we only want the cars with 8 cylinders and greater than 200 horsepower. I think it's just the same table. Yeah, same table. So essentially cars that have 8 cylinders also have horsepower over 200. So it gave us back the same table, but let's try something else. Let's make this 230, greater than 230. We get a smaller table here because we've constrained our filtering criteria. If you put, and you can put commas here, keep going, keep writing your expressions if you wanted. These are combined with the and symbol. I think I point that out here yeah. So these are combined with the and symbol. So this is a logical and. Cylinder equal 8 and horsepower greater than 200. You can also use or using this single pipe here. So you could put an or here. Let's just do it. So this says, give us the cylinders that are, let's move this down to say 150. So cylinders that are equal to 8 or have horsepower greater than 200. This will give us a longer list now. Let's move this down to 100. So now we got some non-8 cylinder cars because we used the R, but their horsepower is above 100. Okay, so you can combine your expressions there. Any questions on those operations?
There's one question. It's does R remember column names like IntelliSense? I'm not sure how IntelliSense remembers column names.
I don't even know what IntelliSense is. It sounds like a delightful thing that I need to learn about. I like the name.
Hugh, do you want to unmute and explain?
Yeah, if you want. Yeah.
Yes, hi everyone. What I mean is that I, instead of me remember the columns cylinder CYL,
yes,
R can recommend me that there's a column called CYL.
Oh, I got it. Okay, like tab completion. Is that what you're talking about?
Yeah, that's
okay.
Right.
So let's try this. So filter, if I push tab right now, and this is in RStudio, by the way, which is important. You'll notice that, okay, so let me describe what I did. So I'm gonna do filter, open parentheses, now I'm pushing the tab key. We get this list, and this gives us the list of all the columns that are available to us. If we were to type CY, it will subset down to it, and then we can hit return to have it complete. Okay, is that what you're asking about?
Yeah, thank you so much.
Yep.
And the other question, Ryan, was if they accidentally overwrote your empty cars, how can you get it back?
Okay, a couple things. So a couple thoughts here. So one thing, when I did these assignments, I assigned it to a new data table here. So that helps you do that. If you made the mistake and said empty cars instead, in general, you've written over empty cars. So a couple things, you could restart your R session, you would get empty cars back. But in practice, you're probably going to be reading your data in from a CSV file, for example, or some other data source. You would just need to reread in that data again to essentially get back the original thing. Okay, so a couple ways. Just be careful with your variable names. If it's a built-in data set, you can just reload R. But in practice, you're going to be reading this in from some source file or some location. You just want to reread that data in again. Okay. Let's talk about this really awesome, extremely powerful piece of dplyr here. And this is the group by and summarize examples. Let's look at our empty cars data set again, just to understand what's here. Let's say we wanted to compute the average or the mean miles per gallon for cars of a given cylinder. So 4, 6, or 8. We can use this group by summarize version of this in order to get the answer. So the first thing we need to do is take our empty cars data set and group it by the variable of interest, in this case, the cylinders. Okay, so let's do that. This actually doesn't do anything explicitly to the data. Nothing has been changed aside from the way in which R thinks about it. So let's look at this empty cars grouped variable. It tells us that there's some additional things here about tibbles and so on. Let me not go into that right now, except to say that now it tells us that this data table is now grouped. It's grouped by cylinder, and there are 3 levels, if you will. There are 3 groups associated with 4, 6, and 8 cylinders. Okay, now that we have this grouped data here, we can now use the summarize command that takes this group thing, and we compute a new column on that data, the mean miles per gallon. This is the name of the column. We could call this anything we want. We could call this Ryan if we wanted to, or whatever, but be descriptive. Call it what it is. So this is the mean miles per gallon, and we give it an expression, the mean miles of the miles per gallon column. Let's take a look at that. And let's take a look at the output. Cool, we got a new table here that has the grouping variable, the cylinder, 4, 6, and 8, and this new computed column that took the mean values of miles per gallon within those groups. So perhaps unsurprisingly, cars with fewer cylinders have better miles per gallon than cars with more cylinders. Okay, so that kind of makes sense as well. But anyways, we did a relatively complex operation in just a couple lines of code here. We're going to see an even better way we can work with these functions here in just a minute. But before I do that, I wanted to know if there were any questions on these fundamental data manipulation verbs. And we can have questions at the end too. If people...
We have a question. How can you view the groups that group by creates?
That's a great question, and I've had that same question. As far as I know, there's no nice way to see that.
I think if you take the object and look at the attributes.
Okay, like this?
Yeah.
Okay,
I could be wrong, but.
Well, okay, yeah. So attributes.
Attributes, yeah. When you go in the other way.
Okay. Okay. Interesting. I've never done this. I mean, it's kind of useful. Oh, look at that. And then we can go groups. Oh, this is. I didn't know this, John. This is great. We can do that. And then, okay. Little detail. Happy to talk about this later. There's some details here. There should be a better way to visually see this, I would think, through RStudio. We should be able to visually see this. As John has pointed out here, there's a more advanced ways we can dig into this and see what they are. Let's save that question. But if you do type out the actual data frame and look at it, you can see kind of what it's doing here. Okay. You could also check it as well. So let's take a look at get to the summary here. Let's look at this. You could filter down. Let's say you didn't trust the calculations. Okay, you were concerned about what it did. You could filter down to this value and then compute the mean miles per gallon on that explicit filtering that you did, and see that the data matches up with what you had. Okay, so great question. I think RStudio should have a visual way to see this a little bit better, and there is a way to dig into the actual object here in a variety of somewhat complex ways where you could actually see what these data tables are. All right. Okay. 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 I think we're doing okay time-wise. The next section is a little bit shorter, but I want to talk about now a really important piece of the puzzle here, this so-called pipe operator. Okay, so this pipe operator allows us to, as you might guess from the name, make data pipelines. This is what the thing looks like. It's a percent sign, it's a greater than sign, and another percent sign. It's very strange. You have to type those 3 characters to do it. There's a keyboard shortcut in RStudio that I never remember. So like Shift Command M or something, I forget. But anyways, this is the pipe operator. Think of this as something that takes something on the left side of the operator and feeds it into the thing on the right side. Okay, that's what this is like, a little bit of an arrow thing on the left side goes into the right side. It's like taking an input and piping it in to a function like those data manipulation functions that we just have been talking about. And so this is the idea here. So take a tidy data frame, you pipe it into one of these dplyr verbs, and it produces a modified data frame. Okay, remember in the tidyverse, the first argument of these verbs is always a tidy data frame, and it always returns a data frame in the back end. So you get a data frame in and a data frame comes out. That's really important for these pipelines. Let's see why. Here's the template. If we take a tidy data frame and pipe it into the mutate command, it gives us a new data frame with an additional column. We take a tidy data frame and pipe that into the select verb, it produces a new data frame with only the selected columns, and with the filter and so on, it produces a new data frame with filtered rows. Okay. Well, let's take a look at this. Okay, right, that's the idea here. Let's take a look a little bit more with the pipes, and then we're going to wrap this into this concept of a data pipeline. These two lines of code do exactly the same thing. They look different, right? Different syntax here, but they do exactly the same thing. Can you see what's similar and what's different between these two lines of code? Okay, yep, please, thank you. Great, what's similar, what's different?
The second line uses the dplyr functions, the pipes, and the first one is just like using the filter function. Yeah.
Yeah. Okay. So this is kind of how we use these dplyr functions in those examples we just looked at, and this is another way to use it. Let's see what happens here. So really two things have happened. One, the input data frame has been taken out as the first argument. It's no longer the first argument. It's been transported over here to the front. We've added a pipe operator, but then we called the filter command just as before. Okay. But we've essentially removed this first argument. Okay, so note that in this dplyr function notation, this first argument is still empty cars. Okay, it's just written a little bit differently. Cylinder is, this expression here is not the first argument, even though it looks like it's the first argument in the function. This pipe operator just changes the syntax around a little bit. Okay, so that's the only thing. It takes the first argument, sticks it in the front, and adds a pipe. Okay, we'll see why that's really cool here. Take a tidy data frame, pipe it into a verb, we get a modified data frame. There's no reason we couldn't just take that modified data frame and pipe it into another verb. We get another modified data frame. Okay, generalize that to the idea that we can take any input data frame, pipe it into a verb to do one operation, pipe it into a next verb to do a different operation, pipe it into a next verb to do a different operation. This is a typical data analysis. If you were to do things in Excel, for example, a lot of times you will do these things kind of piece by piece. Like you go and make a column, and then maybe you make a formula in one cell and you click and you drag it down, and then you do a different operation in another cell and you click and drag it down, and that kind of thing. We are sort of encapsulating this here in code in this dplyr pipeline. So let me give you an example here of a more complex pipeline. Let's say we want to do the following. Again, this is really trivial, kind of contrived and so on, but please sort of think about this in the spirit as opposed to the very specifics of this kind of silly data analysis task. So I want you to do the following. I want you to take our empty cars data set. I want you to get rid of cars that have one cylinder. I want you then to compute the mean horsepower grouped by the number of cylinders. I have a typo here. Cylinders they have. Then I want you to order the results by descending mean horsepower, that thing you just calculated. And this is the pipeline here that does it. We take the empty cars data set, we pipe this into this filter command and say, give us everything except the ones with 6 cylinders. This removes the cars with 6 cylinders. Oh, I'm sorry. I'm getting ahead of myself. I actually did mean gears here. Okay. We want to group by the number of gears, then compute the mean horsepower using the summarize command, and then arrange this in descending order of mean horsepower. Okay. And the cool thing here is that this code kind of reads how you'd say this in English, right? Empty cars, filter out the cars that have 6 cylinders, then group it by the gear and compute the mean horsepower, then sort or arrange the results in descending order of mean horsepower. So the code kind of just reads just like English, which is really pretty cool. And the idea is, obviously you'll need practice and expertise with this, but kind of the idea is if you can say it in English to this level of detail, the dplyr code almost writes itself. And you can do these fairly complex operations fairly quickly by typing out these kinds of pipelines. So let's take a look at what this looks like in R here. Okay. So here's the whole pipeline here. Let's just run it so you can see what the output is. And we got a summarized by the number of gears, the mean horsepower, and it's ordered from high to low, from mean horsepower from high to low. So the results come out as expected. Sometimes you might want to look at the individual steps of the pipeline because it's doing lots of stuff under the covers. In RStudio, it's really cool. All you have to do is take and copy the piece of the pipeline that you want to run. Make sure you don't copy the ending pipe. If you have a pipe here on the end that says that's like a continue expression, it expects to have another function after that. So just copy to the pipeline where you want to go without the ending pipe, and you can paste that code, or you can hit Command Return, and you can see what it did here. It took the empty cars and got rid of cylinders that are that aren't 6, or sorry, got rid of cylinders that are equal to 6. So you can see that in the table here. We can then take the next step and execute that. This tells us that we now have a grouped table by the gears, and there's 3 of them. We can summarize by the mean horsepower. Let's run that. Okay, we did. But notice that they're not ordered here, and then we can arrange that here at the very end. Okay, so now from high to low. All right, so we did a fairly complex, if you will, although trivial kind of data analysis here, but we were able to do it with these data pipeline, with these data manipulation verbs and pipelines that allow us to, in a very human readable way, attack and solve this problem. So it's a really effective way to do this. I'm writing these dplyr pipelines all the time in my daily work, and it's really just a critical piece of how I work with data. Just some recap summary. I won't go through that because we're getting close to 11 here, or it is 11 o'clock. Here are some resources here that you might want to take a look at. Going back to our tidy data example, Hadley Wickham, the person I mentioned before, has written a paper on this. You can take a look at this. He goes into more detail about tidy data, the ideas behind it, the ways in which data can be messy. It's a nice read. It's not too technical, I think, probably, even if you're not into the sort of the hardcore data storage structure things, I think it's still readable. This is a great book here, R for Data Science. If you haven't read it, this is like, and you're an R programmer, this is a must read. Everybody in the ARC, whether you're a beginner or an expert, this is a must read. I think for beginners, it might be slightly advanced, but they take it really slow. I think a beginner with some careful reading and really pay attention to the code, I think even our beginner could probably go through this book fairly straightforwardly. It may not be easy, but certainly approachable. I talked about the tidyr package. We didn't talk about any of the functions there, but if you want to tidy data, this is the place to go and you can read about it. We've also put together a bunch of cheat sheets. These are provided by RStudio for these different packages here. They're on the cheat sheet repository. You can go here and take a look at some of these things. And this is about importing data here that can be helpful, but there's other cheat sheets here as well. So great. So I think, yeah, just 11 o'clock here. Let me open up to any questions that anybody might have about this. And obviously we can, if people have questions throughout the weekend, you can ping me as well.
Hi there. The only question that I believe I have is how this differs from using a pandas library in Python is.
Yeah.
Like going back to that question I had earlier about the grouping, I think it's because Python would store it as its own separate object, but here it's just returning a data frame, correct?
A little bit. The group data frame, as we saw in those attributes, it's actually a more complex object on the back end.
Oh, okay.
So like if we do attributes, oh goodness, what was it called? Let's scroll up here. What did we call it? Group, yeah, this guy here. So this is actually called a list in R. It has a bunch of attributes. Think of these like fields or something like that in a Python class. So like this has a names field and row names and so on. So this is more than just a data table. Just so happens that in fact, all these groups are actually stored in this data table, which itself has another set of values in them. So a complex data table.
Yeah,
So,
I can see the complexity of this now. Definitely.
yeah, it's complex. So you're right. So Python, I think, yeah, deals with these things in a more traditional approach. It's complex on the back end. But okay, Pandas is a great question. So Pandas does a lot of these same ideas, and certainly, actually, Pandas was inspired by some of the work here with dplyr. And so you have the group by operations and so on, does lots of the same things, sort of maybe in a different kind of sort of way you go about them, but lots of the same ideas and concepts. So
Yeah, thank you.
thanks. Great. Okay, any other questions? So I'm happy to answer more later as well. All right, John, how's our queue going? Anything?
Nothing in the queue.
Ryan,
Oh, yes.
can you
Yeah.
can you show us an example of how to use the mutate command along with the filter, group by, summarize, and dplyr? Like,
Yeah,
say I want to, yeah.
Okay. Yeah. So let you could imagine here. Well, sorry. Let me go back to my R code here. So let's say you wanted to. There's no reason anywhere in this pipeline you could mutate a new column in. So we could mutate new call equals. Let me get mine. Just contrived here. Let's take qsec times 100. Okay, this is going to give us a new column here. Completely sort of bogus, but for the sake of the examples, we have this new column here where we mutated on something new. No reason we couldn't do a filter here now. Filter new call less than. I don't even know what these values range here. Less than, say, I don't know, 1750. Okay, so now we're going to filter these rows there, and then we can just continue. So you can literally update your pipelines by sticking these verbs in the places in the pipeline where you want them and have them. So any of these verbs can go in any of these places in the pipeline. And it's just all up to you about what you want to do and how you want to do it. Does that make sense?
Thank you.
Thanks. Okay.